The peripheral nervous system is a marvellous thing. It allows the brain to communicate with the rest of the body by sending signals. One of these signals is pain. In the UK, a third of the adult population is estimated to be affected by chronic pain, and this pain is now treated by administering continuously anti-inflammatory drugs or painkillers. Here at the Next Generation Neural Interface Lab, we are very interested in how pain is transmitted in the body. We believe that if we were able to understand better how the pain signal is transmitted, we could actually create some new way of managing pain. At the moment, the best way to interact with nerves is by using cuff electrodes. However, these electrodes are very invasive and are not at all selective. So what we want to do is to use light instead of electricity. Why light? One of the most interesting things about electromagnetic waves, and therefore light, is that it can travel through matter without touching the tissue. So by shining some light on a tissue, we can actually be able to get information of the structure of the tissue itself. It's kind of what we do when we use a microscope. The only problem is that a microscope is not enough. It doesn't give us enough resolution to detect such small signals as the one that happen inside a nerve when a signal is passing through. So we're using a technique that is called optical coherence tomography, and this technique is more or less like ultrasound, but instead of using sound, it uses light. So at the moment we are running some experiments to understand if this technique is actually viable. So if it is, and we are able to understand the signals better, we can actually create some new techniques to manage pain that can be very useful for people suffering of chronic pain and improve their lives.